Hello, everyone. This is a very awkward situation to get a countdown to start a meetup. Welcome, everyone in attendance, and welcome, everyone. The camera is in the back there online. Good to see you here, and I hope there are some people online as well. Good to see you as well. Thank you all for coming. I know June is usually, at least here in Norway and here in Oslo, a pressure cooker. A lot of stuff happening, a lot of things to do. So we truly appreciate all you guys joining us here, finding the location, finding the room. And of course, we also appreciate the people joining online or actually watching this recording later on YouTube. We also appreciate that. But we mostly appreciate the people actually sitting here. That's of course true. My name is Raoul Wolf. I'm one of the organizers of our meetup, together with my two colleagues, Bethan and Henrik, who cannot be here today, unfortunately. But we got the wonderful Nikolai in the very back helping us out with the streaming and recording setup. Truly appreciate it. Thank you. And as you might be familiar with, those of you that have been here before, we usually start with a bit of trying to get you to present next. So all of this is a community effort. All of these meetups essentially thrive on people like you and like Chi here that are willing to step up and present. You can present whatever you want. There is really nothing. Well, some things are, of course, off the table. So it would be great if it's somehow related to R. That makes it a lot easier to present, of course. But don't be afraid. If you find something really cool and useful in your data analysis and you want to share and talk about it, please feel free. Contact us, contact the organizers, and we'll make sure you can present. There is really no thing as too basic. We think during the pandemic, we had a few too many package developers, I think. And we set the bar maybe a bit too high, so maybe people got a bit scared. But after the summer, I'll give a presentation. I'll bring that bar all the way down, so you'll see how basic it can be, right? So again, please, if you have something you would like to share, please get in contact with us. Make sure that we as a community here can continue. And it's one of the great, let's say, success stories of this community is actually today's presentation. At least I would like to think so. I was actually wondering, since when do we know each other, like meetup-wise? Was that 2018, 19?
2019.
Right,
yeah,
right.
Yes.
Because you've presented at this meetup before. You've also presented at Our Ladies. Big shout out to Our Ladies if you're watching in the stream. And now, after months actually of discussing your presentation, now finally, well, I guess a certain pandemic is still not gone and still very much alive, but now we finally get to hear from one of the smartest people at the Norwegian Institute of Public Health how to use R not only as a sort of academic stats language in obscure niche fields, but to actually use it for something really important for society, and to not only have it functioning on one local machine, but on like a much grander scale.
Yep.
With all of this, the floor is yours. I'm looking forward.
Thank you very much for the great introduction. I'm going to stand there. Yeah. Okay. My name is Chi, and today I'm going to talk about a project and a team that I'm very passionate about, which is Sykdomspulsen. It's an automated public health surveillance platform. My contacts are there, and if you want to know more about the project on GitHub and the website, the links are there. And I will repeat that at the end. So, yes, a little bit about me. I came to Oslo in 2016. And I started doing my PhD at OCBE. So that's Oslo Center for Biostatistics and Epidemiology at the University of Oslo as a PhD student in biostatistics. And then COVID started in 2020. And shortly after that, I joined FHI at the Sykdomspulsen as a researcher, but it's more like a data science job. It's a statistician and art developer. So there I was doing reports, as you can see, but it's not just any ordinary reports. So about my participants in this R community, I joined the Oslo R in 2018, and there I gave 2 talks in 2019. As you can see, I was super enthusiastic, and today this is a talk I'm doing here. So a little bit about this talk, so that we know what to expect. So if you're not working in public health, so you probably already know quite a bit about public health surveillance. But still, I'm going to give a 10 minutes primer on what this is, how the data is generated, and how is it different from research, since most people here are researchers in academia. And then it's public health with data science too. At the Sykdomspulsen. So I'm going to talk about that for 10 minutes. Talk about we make reports and many more things. And we use open source tools, R, GitHub, Airflow, things like that. And we also follow the R tidyverse principles. So that's the data science part. And then I'm going to show a case study. A day at the Sykdomspulsen. So that's 20 minutes. That's about R and how we can use what we can do with the publicly available data and try to make a report from the data to report, and I'll try to automate that. And I hope you are not bored by then, so I have a bonus there. You can use our package, the SPL maps and SPL style for maps and for a more customizable ggplots, basically. And I also have an auto report tutorial that's on GitHub that everybody could use. So in the end is SPL in production. That's 5 minutes. Because I'm a statistician. I don't know that perfectly. I can only give introduction about that. So that's on the task scheduling, automation, and how we work as a team, and yeah, so on and so forth. So between these 4 blocks, I can take some questions from YouTube. But if you have any questions during the talk, you are free to raise your hand, and I will just stop. So I have a timeline, but usually we run over time. So let's just have a discussion and be relaxed about it. All right. Disclaimers. So the opinions are my own, and they do not reflect the view of FHI. Reports showing these talks are for education purpose only, and the regulations and the data about the data are constantly changing. So just so you know, that make sure you check the official website. All right, so the first block, public health surveillance in a nutshell. Where does the data come from? So we have all experienced this whole 2 years of COVID. I'm sure everybody knows more or less what's going to happen. So when a person is exposed with the COVID virus, the first thing happens is some symptom onset. So the person will most likely do a self-assessment, either by a COVID test or to just measure your temperature. At this point, you don't really generate any data. And then is the health behavior. So you will likely search information on Google or you will go to the apotheke and to try to get some medicine, or maybe you are sick and you will ask for a day off from your work. So at this point, the data might be collected. And then next, when you're very sick, you go to the physician's office. And if you're very, very sick, you go to the emergency department and become hospitalized. So the data will definitely be collected here. And finally, when you do a PCR test, it's official. Now you have COVID. So that data is mandated to be sent to the registry for public use. For the official use. So the data collected by the health professionals first, and then it gets sent to regional and national PH authority for action. So that action is to decide whether you should do a lockdown or we just business as usual. So this slide comes from the Coursera course, just for credit. Yes, so a bit of framework, the 4 Ws and 1 H. We all know why we have to collect the public health surveillance data. So what do we collect? It's not just COVID and influenza, right? It also has a mortality, cause of death, and chronic diseases like cancer and diabetes. Some about the weather and the natural disasters, because the outbreak might happen after a hurricane, for example, and some others, like the firearm injury in the United States. That's actually a public health issue now. When and where? So for the influenzas and the COVID, these are routine collections, so daily or daily. And for the yearly, that's like mortality is collected every year. And some are occasional, so like after outbreak. After the natural disaster, for instance. Where for the routine collections, it's for the different level of geolocations for regular collections. And if it's an event related, of course, you just collect it at the event. Who does it? It's public health authorities that does it. So in Norway, that would be FHI. In America, that's a CDC. And in the UK, it's, in England, it's a public health in England, and so on. Regarding to how you do it, I'd like to use this phrase, CADA, surveillance cycle. So that's a collection, analysis, dissemination, and action. We will see that a lot in the later slides, so I will not elaborate now. So just to note that it's a public health authority that do the surveillance, but this work is actually contributed jointly by many actors, like WHO, that's international organizations, the Red Cross, that's NGO, in academia, that's researchers, and the public, because everybody is involved and they have discussions and so on. So since we are all working with data in some capacity, I think we are interested in what data we can get online. So the public health authority, they publish data. And first, it's going to be picked up by the local media. So in Norway, that would be VG, Aftenposten, and others, and they make very nice dashboards. Then it's the international media, Financial Times, Economist. They also make very nice dashboards, and for many different countries and regions. So that's very interesting to look at. And then the most interesting thing, I think, is about these open source projects on GitHub. So the GHU, that's the Johns Hopkins University's COVID data repository, that really started at the very beginning of the pandemic. And in Norway, there is this COVID-19 data repository that they do a very good job. I don't know if any of the creators are here, but they do a very good job. I enjoyed following that. And in the end, this Our World in Data, that's a platform with data and with even research. So this would be the GHU repository. And that's the COVID-19 Norway data. It's I believe this is a hobby for some people. They did it in their free time, I believe. And that would be our world in data. As you can see, they have quite a lot of topics of concern, and they really did a very good job collecting all the data and write articles about it. So yes, so this public health compared to research. Since everyone here is, well, most people here are researchers, I'd like to tell you how it's different. So for this surveillance cycle, first is the collection of data. In research, you work on fixed data sets, more likely. And in surveillance, especially surveillance with outbreak potential, you will work on new data and from multiple sources collected every day. So that means you have to do the data aggregation and cleaning every day in a robust and consistent way. So that's the first challenge here. The next would be the analysis. In research, you develop new methodology. You do many fancy work like neural networks and so on. That's not going to work with public health surveillance because you don't have the server to run that. So what we have to do is the basics. We do descriptive analysis. We do counts, the trend, and a percentage, for example. So that challenge would be the flexibility, how you scale it up for different age groups, for sex, for time granularity, weekly or daily, and for the location groups. The third is dissemination. So that would be how you communicate your findings. In research, you would do a journal publication. That's the most common way to communicate, right? But it's a bit slow. For surveillance, you will do a lot of reports, graphs, numbers, and data sets. And the challenge would be to scale that for different levels of authorities and how to do it in a consistent way because you have to produce reports every day. And the last one would be the action. So that's a characteristic about surveillance because there is a need for policy responses, effect immediately, most likely. And that requires that the data scientists or researchers to be able to develop new tasks very fast. So you can't take half a year to develop something to track, especially when it's like vaccine doses, that you really have to respond fast. And the surveillance methods, they don't live without research because we need the researchers to develop fast and robust methods so that we can use it. And it doesn't go without research. Yes, so that's the first block. If there is any questions, YouTube?
There is one question.
Yeah.
When we use public data available online, can we use it or need to send a courtesy email or some in that organization?
Okay, I'm not sure. I think you don't have to because it's public, then it's public, right? But maybe when you are using that for your reports or if you are producing anything, it's better to just give a credit. I think giving a credit is quite important. Yeah, so that applies to using others' work, right? Yeah.
So out of the actors you've mentioned, seem to have omitted all the private sector and like recently with the whole connected devices and stuff of that kind, they actually have a lot of information about our health status.
Yeah.
Like, our search history. If we start looking for like, do I have cancer? They would just kind of like those type of searches. So private sector also seems to have some information about health status, and they do have that at a large scale. So is there any collaboration between FHI and some like large data providers or private actors?
Do we? I'm not sure. Yes, I admit that I have omitted the private sector. So I'm not very familiar with that.
It's mainly with the public sector, also hospitals, other organizations.
Yeah. Okay. Yeah.
A question
question, because in a very unusual situation like the COVID outbreak, where obviously a lot of things in the beginning were happening extremely fast in terms of data generation, etc. I imagine the entire process of finding out where the data is coming from here in Norway only, but then also probably every data source had a very different approach. You're smiling.
Yeah, exactly.
Very different format of data, etc.
Yeah.
How was it possible to actually get a hold of that in such a short amount of time?
Well, at the very beginning, people just work a lot overtime.
Can you repeat the question for the people?
Yeah, sure.
Right.
Yes. So the question is about how do you react so rapidly at the very beginning of the pandemic when you have so many different sources of data in different formats, right? So in our experience, in Sykdomspulsen at the beginning, there was only one person who was developing it, actually. And he worked a lot over time in order to do that. So at the beginning, there was really not a good solution to it. You just work. But with R, it actually helped a lot. So we have this way of working where we have these rules of how we want to do censoring, and we write functions, right? You write a function, and then your input output will be easier to adapt to the changes. So that's where the R comes into play. Because when you scale up, like you have the MSIS data, which is confirmed cases, and you have hospitalization, and they have different rules for censoring and how they come, and it's tough. There are many different registries that are involved in this. Yeah, but at the SP, it's our team. We are working on this standardization so that it becomes a bit easier. But it's a very large work. Yeah. Okay, so now I'm going to talk about data science, not just the COVID. All right, so surveillance with data science tools. That's Sykdomspulsen. So Sykdomspulsen, it's a Norwegian. It means disease pulse. I don't know who made the name, but it's been there since 2012. Right now, we are a team of 8 members, counting only the regular members that are full-time here. So the project started in 2012. It was very small at the beginning, but it had a key role in the COVID pandemic, and we expanded very rapidly from 2 to 8. So we are a real-time surveillance platform. So we are real-time because we receive data daily, almost daily. For the mortality, it's weekly or yearly. We receive data daily, and we do analysis every day, and we deliver every day. And we do public health surveillance. That's infectious diseases, including COVID and influenza, and mortality. We are platforms, so we do data cleaning, censoring, statistical analysis, and graphs reporting all together. And we are automated using R. So that's Sykdomspulsen in one phrase. And the product we are most proud of are the automated situation reports that we call auto reports. So in Norway, we have 1 nation, we have 11 counties, and 356 municipalities. So these reports, one for each location, we produce it every day, and it's saved into a folder before 7 a.m. And these are used by the FHI leadership and the Ministry of Health. So they look like this. So these are the county reports, one for each county with a date. And that's in a Word document, so you can actually open it and edit the text or double check the quality. Inside, It looks like this with some preformatted text and with the updated number from the latest updated numbers from the registries. So it also has tables, and it also has a lot of graphs. And for the national report, it has 35 pages, it has 17 tables and 21 figures. So you can do it by hand. But if you have to do many reports in the early morning, then that's a lot of work, and you have to pay people to do it because it's overtime. So automation saves the time and the cost. So historically, before 2020 December, the reports are made by hand in the very early morning for selected locations. For example, you can select 5. You make 1 nation and you make 3 counties and 1 municipality at most. These are just the background information on how you can estimate the overtime. And for the auto report, the data is lies in the secure zone, and it needs to be taken out and processed and make the reports. We use 8 CPUs in parallel, and it takes 40 minutes every morning. In 1 year deliveries, we can make so many more compared to the manual reports. And we can have 0 overtime hours. And we don't have to hire people in addition to do this work. And we save the Norwegian government 700,000 kroners. And that would be this amount in international currencies. So this is the amount of overtime that you are able to save by automation. And we do more than just reports. I'll give you 2 more examples. One is the outbreak detection from the general practice, the fastlege consultations. This we do it daily and for different kind of analysis. So different age groups, the consultation codes, locations, and for different years. That's 100,000 analysis, sorry. And this is delivered to the municipal public health authorities via Shiny websites and email reports. Yes, we also have a Shiny website, but it's not publicly available, so I cannot show you, unfortunately. And for another outcome, that's the excess mortality monitoring. We do it weekly, and it's not that amount of data. We have different age groups and counties, and we report that internally and also to the international networks, and they can use this result or data to include in their website. So this is a business talk. We deliver the actionable intelligence using the reports website, graphs, and emails, and using our tools. And the people involved are people at FHI and the data registries at FHI. And we deliver to different levels of our government and to the public. So that would be on GitHub. We do have a GitHub surveillance data. It's on FHI.no, and the medias, they also get the data from the GitHub. So yes, of course, it's also delivered to the international organizations, networks. So this would be our secret of doing data science, the 3 keywords: the tools, the team, and the rules. The tools. So this platform, we use R because it's developed by statisticians. In our team, we have 3 statisticians with a PhD level of training. We use a free open source solutions so that we can do a flexible and fast development. Just to look at how many R packages there are to do different kind of tasks. So that's why we are more flexible than using maybe commercial products. And this is for free, of course. So we have been using our packages that are already there, developed by the others, and we also have our own set of packages, which we call SPL worse, because everyone calls things worse nowadays. So in one of these packages, we have different location names and granularities in English, in Norwegian. And in another, there we can make maps for counties, for municipalities. And of course, we use GitHub and Airflow and Docker and the CI/CD. So that part I'm not too good at it, so I'm sorry about that. Then yes, about the team, we have 8 people that are regularly 100% here. We have a project manager, we have a coordinator, and a web designer. We have 4 developers and 1 engineer. Everyone uses R and Git. Well, the level varies, but everyone is able to use R and Git, including our manager and coordinator. And we have this monthly training. We call it a Tuesday learning hour. And we do train people to debug, and we have a WACT week that in the industry, some call it engineer of the week. So that person in that week is responsible to debug and to solve the problems. So we are only like 8 people, and we are able to do a lot of work, automate a lot of work that inside FHI that they're not able to do. So these are the rules. So we use the tidyverse principles, which are human-centered. We use R. We develop for people. We are not like hardcore developers use C or super difficult languages, but we just want to use R for the sake of producing something instead of sticking to the software development things. We try to be consistent with our namings because we have so many different tasks, so the names they have to be consistent. And we develop code that are composable, so they can be broken down into pieces, and they are easy to scale up in the debugging. So okay, if it's the data processing that's problematic, or if it's a reporting is problematic, that nothing shows up. And yes, we're inclusive. We use open source tools. We train people both inside the team and outside, and we like to share what we do on GitHub and here. We want to switch from doing people's data work to develop tools that everybody else can do their work better and faster. So that's what we hope to do. And one last slide for this section, that would be what we can do with the surveillance challenges that we are facing from the CADA, the collection, analysis, dissemination, and action. For that, we use our R packages to do it. So yes, so these are the more general introduction about what the SP does. Yes, is there anything? Yeah.
Not from the public.
Great.
Online.
Yeah. Yes.
It wasn't clear from what you told whether when you detect something that is like very abnormal, there is like a specific trigger that would alert relevant stakeholders, or whether it's like just every day or every week you would have at the same time report it. Like, is there kind of like a emergency detection that would say, okay, regardless of the regular time, now there's something very special happening.
Yeah.
We need to get someone's attention that can check it out. Is there something like that?
Yeah, so that's a question I had when I first joined, because I didn't really understand what's so important about doing outbreak detection here. So actually, the people who are mostly familiar with outbreaks, they are the local municipal public health authorities. They will know first. So if there are a lot of people suddenly asking for consultations, then they know it first. And then what we do is we collect all the information, and so we do this reporting so that the top management at the country level, they know, they will have this situational awareness about how the situation is. And of course, with the infectious diseases, the situation is always changing. Then sometimes we are just told, okay, you don't have to do the, for example, the hospitalization anymore. Then they will tell us. Or they will tell us, okay, now you have to do the monkeypox. So this comes from the top. Yeah. So we do not decide what we can surveil. Yeah.
Like the switch of regime, the switch of mode of the thing is not automated. It's still...
No, there are, so at the Sykdomspulsen, we are like the data science teams. We don't make decisions. There are other teams that are involved in this process. There are so many other teams involved. Yeah, so they will have regular meetings about what to focus on and so on. Yes, so next part is about R and how to make reports with R. So they at SP, we received a request. How is the situation of the COVID trend in the country and 11 counties? We need a report with map, and we need it to be delivered every day. So that's a very common scenario that we can face. So first, you ask questions. You want to know what data should be used, from which registry it need to come from, and what specifications, which age groups, which age groups and the sex, and the locations, and what time. You probably want a daily and a weekly altogether. So what kind of metrics and analysis? Do you want just the numbers, or do you want the trend or an outbreak, like alarms? And what kind of delivery? Do you want a report, a website, or do you want just tables and graphs or emails? So what is the deadline, and how often do you want it delivered? So in this very particular case, we have an example from the COVID cases in the MSIS registry, that is the Norwegian surveillance system for communicable diseases. We want for all age groups, so altogether, we don't distinguish the young or the old. We want it for both stacks together, and only national and county. So for the metrics, we want a number of new cases, and per 100,000 for that county, and we want like a 6-week trend for that week. Is it going up or is it going down? For the delivery, we want a graph, so map. And yes, we will, since I'm going to talk about a report, report is also going to be included in the delivery. And the delivery is a daily delivery. So yes, so just to break down the problem, we can break the task down into analysis and reporting. For the analysis, that's like the regular data science task. You do the data cleaning, and you do a exploratory analysis. You can develop your code for one location, and then you extend it to multiple locations, and you can produce a map. For the reporting, you make one report, and then that can be automated to multiple reports so that you can run it automatically every day. So these the tools we are going to use are the packages we developed in-house. They all start with SPL because it's SPL words. So I will explain them in detail in the later slides. And of course, the R Markdown for the reports. So in this example, so demo data is already pre-formatted, and that is publicly available. You can find it if you go to our GitHub, you can find it. So we have saved that data into this package called SPL Tidy. It's called COVID-19 MSIS cases by time location. And we check the column names. It's probably a bit small. So there are like 16 columns that are going to be fixed, that they are in every data set that we use. And there are 2 outcomes that are just for this task. That is the COVID-19 cases number and the COVID-19 cases for 100,000 population. So that would be, per 100K. So when this is probably too small for people in the back. You have to check online for this slide. So we have saved the data for different granularity time and different granularity geo together. So in this data set, we have both daily data and also aggregated into weeks. So as a week in the granularity time. And for the geographic locations, we have the county level and the nation level. And for each of these, there are different location code. That's for 11 different locations for county and 1 for the nation. For the border, that's a very Norwegian thing, because in 2020 we did some this redistricting the counties, or splitting. So the locations from before 2020, they are matched differently. So in that, you actually have to do quite a bit of work of rematching this so that you can actually use data from before 2020. So that's the quite a challenge for the data aggregation part. Yes, so for these 2 specific outcomes, they will look like just like that. It's nothing special here. So we know we want that 2 outcomes. Let's try to plot it to see how the trend looks like. And here is we use ggplot, and we have created this package SPL style so that the style are consistent with the FHI standard, so that they are used everywhere in all the products we produce. So here we use the SPL style column format, and this is one of the plots we are able to produce. And for the formatting, here, these are formatted with the SPL style, and also this year and the week. These are all formatted with the package we have developed. And also that applies to the color scheme. So here we have 11 counties. So these are the cases, absolute cases. And the largest peak, that would be the county 30. So that is Wicken. So that is a very big county. And we might have this idea that, okay, that county has a very severe situation. But that might not be true. If you scale it to the population size, you will see that actually every county has almost a similar situation. It's not that bad in Wicken. So that's why you use this per 100K population to scale to the population size. So the next step, you want to have this analysis for one location, and you can also visualize that information with different colors. So we want to have a 6 weeks trend analysis. So I'm not going to talk too much about the details on the method. But if you're interested, you can check that and check the source code in our packages. Everything is open. If you are not happy with the method, you can also start a pull request and try to improve what we're doing. So for this analysis, we just developed that for one location. So we developed it for Norway, and we are going to use that method for all the different locations. And we just call the SPL alert function with short-term trend. And that will give a result with the trend for each week. comparing the previous 6 weeks for each of these weeks. So when we plot that case with the trend coloring, you can see that the increasing, like here, these are increasing, and the decreasing, these are the decreasing. So this is pretty useful when you are doing this initial analysis. It's quite nice to have this plot with colors. Yeah, so that's for one location. And now we are going to expand that for all the locations, where we are going to introduce this package called a planner. And it's a structured way of doing many analyses together. And it's particularly useful when you are dealing with a very large data set. Because, so for example, if you have one data set that has 400 locations, you have 10 years of daily data, and you have 10 different age groups and 50 different diagnosis codes, then that's going to be a quite large data set. And you probably don't want to pull the data every single time you do the analysis. So what we do is we take it out once, and we plan different analysis, and we just use analysis 1 on this data set. We extract a small data set from this big data set, and we do analysis for analysis 1, analysis 2, blah, blah. So that when we develop code, we develop it for one subset, and then we apply it to all the subsets. And this, of course, it can be paralleled, of course. So this is the R6 class. I didn't develop it, my team developed it, and you can go to the GitHub to check the details. So just to show you how the code would look like when you are using Planner. Yeah, of course, when you are doing this analysis for only 12 locations, then you can just run a for loop, right? But when you have so many different analysis with combinations of age groups and diagnostic codes, it's easier to have one set way of doing things. And using the package in your team is also easier to make consistency, so that the two people don't develop two different kind of ways of writing for loops, right? Yeah, so yeah, so at the beginning we would, so using this planner package, you can write start a new plan at the top, and add some data, and then you can check how the location codes actually looks like. So that would be 11 counties and 1 nation. Then in the next part, we would try to plan, and that is expand list. That's if you use R, it's not too strange. It just creates combinations of different 2 vectors. You just create a combination. So here we are able to create a 12 analysis for the location codes. And if you have 2 granularities, you want to do it for daily, then you will have another 12 that for the location codes and for daily. Yes, so this way you have planned the analysis specifications that you want to do. And in the next slide, we can do the action, which is basically what function you are going to use for each one of these analysis. So inside this function of action, we try to take out one subset of the data. So that is specified by the argset1. So that's only for county 03 for ISO week. After that, we remember that the data we are loaded at the top, that's the whole big data set. So when we have this argset, we are going to take that particular, we're just going to filter that small data set so that we can develop our function. Then for this small subset, you basically run the trend analysis, and you apply this action to all the 12 combinations of argument sets, and you can run the whole thing. So this part is printing a progress bar. It's a 12 out of 12 that is done. When you are having like hundreds or thousands of analysis, it's really handy when you're using the progress bar to see how far it has gone. And of course, this thing can be paralleled. Yes, so after we have the analysis for the 12 locations, actually we are going to make a map for 11 locations for each counties. So the results from the previous step, that's saved into a list. So we would save it together to bind it into one data frame or data table. And we just take out 1 week. And that's how it looks, how the result looks. It's just for this 1 week. And it looks like it's increasing, the COVID cases. We make a map by using the SPL maps function, where you would load the SPL maps for Norway County, and then you fill the colors with the increasing trend or decreasing trend or uncertain. So for this particular week, it's yeah, this is another week compared to before. Yeah, so half of Norway is uncertain, and half of Norway are having a decreasing. If we make more maps, you can see how different they can be, how the situation will evolve. If you do the week 40 and week 42, week 44, you will see that, okay, from the uncertain cases, now it's actually getting pretty bad. So that's just fancier ways to make plots, make maps. In this way, you can also put labels on top. So this package is public. You can all use it if you are working on Norway maps. And all the documentations are all written, so you can just copy and paste and change and use your data. So the next is to make the report. So we start from a static report with R Markdown. What you need is use the style and a report, R Markdown. So those two will make you a basic report that will print out the report Docx. So those two are inputs, and that one is output. If you want to automate that, you need to use an additional script, R. So this tutorial is available on our GitHub, of course. So first step, you create a style, Docx. So this part, you don't have to use the header, but this style, it basically gives you this the format of how you want the title to look like. So if you want to change the title to a different color, you have to do it in the style, Docx. Then inside the report R Markdown, you will reference that style in the header. And let's include that map we just made into this report. And when you knit this R Markdown, these are the text. On the left, it's a text in the R Markdown, and on the right is what the report will have. So the map will be included in a second page. So this is like a static report that you can do by hand via knit or like a random R Markdown. But if you want to automate that, you have to use a script. For example, we want to make a report that has automated, like automatic updated date with today's date. So let's, in this script, we create an object today using this LubriDate today. And there you will write, just create a file that you want to call your new auto report. And in this report auto RMD, you can call this object with R and day. And inside the script, you can render this the R Markdown using the input, and the input R Markdown and the output, because you need to save it somewhere. So the date will appear there as the object you have created. So this is very handy when you have like a lot of graphs that you want to insert into this report every day. Of course, you need to, in the names, you have to specify, okay, it's generated for this particular county or on this particular date. But yeah, once you have done the specifications, it's not really that hard. Yes, so these are really what we use a lot with our work. So SPL style and SPL data and SPL maps with R Markdown. These are really the secrets for making auto reports. So making so many auto reports. And thank you for your staying here for so long. I will give you some bonus. The FG packages, they are freely online. The SPL maps, this one is ready. You can use it for like a county and a municipality and the city ward for Oslo. There are quite detailed documentations on this. And you can change the labels, you can change the colors as you wish. They are all pretty well documented. And then for this SPL style, we have documentations on how to make tables and epic curves, maps, and different color palettes, and the ways to make epic curves. So you can use it and change the colors into what your work or organization needs. It's all open sourced. Just give us a credit. You can use it for your work. Yes, then it's the auto report tutorial. So you can find the tutorials in our GitHub, and yeah, it looks like this. It should be able to allow you to make a very minimal report, and then you just try to customize it into the way you want. So yes, this is a part with R stuff. Yeah.
There were some questions, but you answered them.
Okay.
One of them is if you could share the GitHub link, and that is Sykdomspulsen.
Yeah. Yes. So yeah, the GitHub link, it's on the last page that I'm going to share. Or you can also ask in the meetup discussions, and I can give you the link. Yeah.
Great. And what is the R package used to produce the reports in Word?
Yeah, that is R Markdown, but with a fancy twist with the customizations. Yeah, but it's really just R Markdown. Yeah. Yeah.
Sorry, I have another question. So, is it because the way you presented it, it's unclear whether that be relevant. But in some instances, when you perform quite computational heavy task and then need to output many reports from that computation heavy task, you don't want to repeat unnecessarily that computation step, and you just want to make sure that you can, let's say, do small tweaks on the downstream steps. So that's typically what's done with pipelines, right? Like SnakeMake or targets, where they keep track of when was the last time this particular step was modified, and if that was happening like very early on and nothing has been modified, it doesn't repeat that step and just avoid unnecessary computation. So I don't know for you, because you segment the data quite extensively and it's like very, let's say autonomous from each other. I don't know if that's relevant, but is that the idea of like putting this as a pipeline instead of just a script?
Well, we have so many scripts. The whole infrastructure itself is a R package, but it's a very large R package. It has like 1,000, well, sorry, not 1,000, but I think 150 plus different scripts for different tasks, from data cleaning and so on. And the data, so what's the problem with auto reports is that you have to do quality assurance. Sometimes the upstream data didn't update. That actually happens more often than you would think. Then we have this system that it checks when the data was updated from the top. And then if it didn't update, it will send us email. And the person who is in charge that week will receive a text message saying, okay, this data was not updated. In that case, we have to contact the people who are providing us data. And after they have figured out if it's a problem with the database or it's some other problems, they need to tell us. And after they fix that, we have to run the pipeline again so that the data will be updated.
So the decision to run the pipeline once the data is updated is still like manual?
No, so every day the pipeline is run automatically. We run it manually only when there are problems. And that happens, so the data from upstream, that is usually, there is some error maybe once per every 2 weeks that one of the databases was not uploaded in time. So that could happen. So we have to run it at 10 p.m. again, 10 a.m. again, something like that.
And the sending of emails is done with R2?
Yeah.
What was the package for that?
I don't remember exactly, but later I can show you. It's all in R. Mm-hmm.
There are 2 more questions.
Yes.
Which package is used for the maps?
Yes, so for the Norway maps, it's SPL maps. But if you want maps for other countries, then you have to find your own solutions because we only have the data for Norway.
Mm-hmm. And then if you need to run these codes every time, or do these codes real-time create graphs, tables, and maps?
So with the pipeline, so normally this will run automatically because we schedule it in Airflow. So at a fixed time, this whole thing will run automatically. But for development, of course, you run it interactively, and if there are problems, you have to run it manually. But in most cases, it's all automatic. Yeah. Mm-hmm. Right, so that's questions about production. And here we are going to talk about SP in production. So this is more like IT thing, so maybe this gentleman will be able to know very well. So from the data to report. So the data from different registries, they are in the secure zone. So if you work at the University of Oslo, that's something like a TSD. So we work with, for example, 5 different data sources, and they are anonymized and censored inside the secure zone. And some are using our scripts inside the secure zone, so that it's you just need to click on it and it does the data aggregation there. And then there is this thing called NHN-sluse, so that's a gate. People working public sector or in healthcare in Norway, we all know very well who they are. So at that sluse, the data will be taken out from the secure zone. And that is also automated in Airflow. With after the data is out in the ordinary zone, we can do the processing, the analysis, and the report making outside. And that's what maybe 90% of our work is about. Yes, so about the scaling up. So I have shown you this planner when you have many analysis. This is just one example of expanding list of combinations. And the data pool, we work with like 800 DB tables. And to pull the data is Microsoft SQL and our data table. We don't use data frame because it's too slow. So yes, we develop a code for one plan and run it for all. Convenient in parallel, obviously. So with automation, we use Airflow. So if your data processing at the top, it failed, then of course the downstream will be failing as well. So for some of the tasks, they are every day. For some of the tasks, they are like every once per week, because we only get updated data once per week. So we run like 150 or more tasks. So that task is like data cleaning, processing, and report making, stuff like that. And we have this alert system where we receive email and SMS. And the worst thing when I am on WACT is that I received SMS at 6 a.m. And that means I have to get up and try to fix the problem, and that's not fun. Yeah, so for the quality assurance, that's WACT. There's debugging and the check report output that we have to do, and it's quite important that the data are updated. Yes, so then for the development, we use Rstudio, GitHub, and Docker and the CI/CD. That part I'm not familiar with, but with Rstudio, I can say a bit more. At our team, we use Rstudio Workbench, so that's like Rstudio Server Pro. It's not for free. It costs like 100 USD per person per month, so it's not that much compared to the server cost. And we use GitHub. So when we have new tasks, for example, we want to add the fourth those in the auto report, then we will create a branch and we work on that. And we check each other's pull request. So that I think it's a very good practice, so that people know what each other is doing. Yes, so that would be the deployment, which you need to contact our engineer for more details. We have a contact in the end. So yes, so this is about everything I have. So we are a real-time public health surveillance platform. We are open source. We are efficient and scalable. We use R because it's developed by statisticians. And the links are down there. And for some more references, people can just go and check the references. So this is everything I have for today. Thank you. Yeah. Okay, so if there's any questions, I will take them, or otherwise we can go. Yeah.
What kind of operating systems do you run the full production on?
Linux, Red Hat, I believe. So we have, I think, 3 servers. So one is only for production, so we don't interact with it, and one is for code development. Yeah, we have 2 that we work on.
Is that located on premise, or is this some kind of cloud solution? Or?
I really don't know. Maybe Marie, you know?
I'm also not sure.
Yeah, so I don't really know. I think they are at I don't know. I can't answer that.
Yeah. You don't have to maintain those as well?
Well, the IT part, it's taking quite a lot of work. It breaks quite often, and it's not really our problem, but it's the whole provider that is at FHI that is breaking. So yeah, that's actually a very annoying part. But that we can't really do anything because we don't fix the NHN. Yeah. Yes?
I was wondering, do you have like a systematic way to get feedback from the users of your reports and stuff like that? Like how frequently does that happen? How responsive do you tend to be for these?
Yeah, so there are a lot of different users of our system. So one of the things I didn't show you is actually the KHC website. That's the website for local municipal doctors, the public health officers in each municipality. So they will receive like automated and customized email with customized data for that location that they are interested in. And they send us emails to say, okay, this thing is not updated, or they haven't received this and that, or they say, oh, you did a good job, and things like that. That we can't predict when they will say that, but they do contact us quite a lot. So we do have a coordinator just for that. And the coordinator is able to code in R, well, not code in R, but is able to change the Shiny script so that the latest, if the data is not updated, then there's alert. So our coordinator is able to change that and deploy that to the website. So yeah, we do receive a lot of emails from the users, and yeah. But that's from email.
Are there requests for like additional features, or is that something beyond the scope of what the users do?
The users also want additional features. Right. Yes, they will give us feedback on what kind of characteristics they want, and they also comment on the styles and so on. So quite a lot. So yeah, that's why we are quite efficient, because we interact directly with the users, and when they want something, we just change it immediately in-house, and it's out in 30 minutes. So we don't have to go through a middleman. So that's a different thing from if you have a IT provider who is doing your website. That will cost, and that's also slow. Yeah, so we do it in Shiny.
And then the results in Shiny, they will only be available for the county or...
So it's available for subscribers.
Yeah.
Yeah, so if you are in FHI and you subscribe to that, you can also have that. So this is not publicly available, because for like municipals, there are some small municipals. And then if you have one case for this outcome, then there are these privacy issues. That's why it's not publicly available. Yeah, so. Yeah.
But it's very restricted then.
It is. There is a logon system developed by Ancient. Yes. Yeah. And the data we use are indirectly identifiable. And yeah, things, yeah, like that. Okay, so you can use our stuff, and we are really enthusiastic about R, and we like to have feedbacks, and we like to work on open source projects and so on. So yeah, you're welcome to do a pull request or give us comments.
It's impressive how much you have.
Thank you.
Automated as well.
Yeah, thanks.
The amount of data and
It's it's hard. Yeah, thank you.
Yeah, thank you so much.
No problem.
There was one question that was regarding to something from the previous section.
Okay.
And if it's possible to connect live database with these package, but I'm not sure what these package.
Well, then you need to use the API, I guess, to get the data online. Yeah, we sometimes get data from other countries' public data, like the Nordic region. We get the data from SSI in Denmark, and that we just get it from the website where we API. Yeah. Okay, great. Thank you very much for joining me.